Welcome everyone. My name is Dr. Mudita Juneja. I am from Department of Electronics and Communication Engineering, Tirthankar Mahavir University. The topic for today's video lecture is Reciprocity Theorem. We will also consider the condition for reciprocity in two-port networks. Now first comes the statement for Reciprocity Theorem. So the current I in any branch of a network due to a single voltage source E anywhere else in the network will equal the current through the branch in which the source was originally located if the source is placed in the branch in which the current I was originally measured. So to simplify it, in other words, we can say that the reciprocity theorem states the location of the voltage source and the resulting current may be interchanged without a change in the current. That is, whenever we change the position of the voltage source and the current in any given network, then the responses remain the same. This is the summary of the reciprocity theorem. However, the thing to be kept in mind is the polarity. The polarity of the voltage source should be identical with the direction of the branch current in each position. Now there are certain steps to be kept in mind while solving any network with this reciprocity theorem. The first step is select the branches between which reciprocity has to be established. That is, I can say that you can select the branch with the current and the voltage which you will interchange in the next step and find the currents and voltages respectively. So first you need to select those two branches. Next is the current in the branch is obtained using any conventional analysis method. Third step is to interchange. The voltage source is interchanged between the branches which are selected in the first step. Next, fourth step is the current in the branch where the voltage source was earlier existing is calculated. Now the last step is it is seen that the current obtained in the previous connection, that is in step 2, and the current which is calculated when the source is interchanged in the previous step are identical to each other. So this proves the reciprocity theorem in any given network. Now for the demonstration of this theorem, we have taken two circuits, two networks. One is in figure 1a and the other is in figure 1b. So in the representative network of figure 1a, the current I due to the voltage source E was determined. If the position of each is interchanged in figure B, the current will be same as that in the previous network. Let me tell you what this is saying. It is saying that if there is a voltage source E between the nodes A and B and the current calculated between the nodes C and D is I, capital I, then if the position is changed, that is the voltage source is kept between C and D nodes, as you can see in this figure, the current between A and B nodes will remain the same as it was between the nodes C and D in figure A. This demonstrates or proves the reciprocity theorem. One thing to be kept in mind here is the polarity. As you can see, the direction of current in figure A was this, towards D. So that is why the placement of the voltage source is such that the positive terminal is towards the D side, so that the direction remains the same. So this has to be taken into consideration while solving circuits using reciprocity theorem. Now we will clarify the reciprocity theorem in this figure. As you can see in figure 2, here we have a voltage source of 45 volts, that is E of 45 volts, and we are seeing the current in this branch which is given as capital I. So to demonstrate the validity of this statement and the theorem, we are considering this network. Firstly, we need to find the total resistance as seen from the voltage source side. You can see this will be a series combination of R3 and R4, then that in parallel with R2, then that combination in parallel with R1 will contribute the total resistance. So that is what is given here. RT is equal to R1 plus R2 and that in parallel with R3 plus R4. So the total value of the resistance would be 15 ohms. Now the total source current in this way would be E upon RT, that is the total resistance, and the value comes to be 3 amperes. As according to the current division law, we can see that IS will find two paths, one of resistance 6 ohm and the other also of resistance 2 plus 4, that is 6 ohms. So half current will flow in this direction and half in this direction. So the value of I would be half of 3 amperes, that is 1.5 ampere. Now to demonstrate the reciprocity theorem, what we will do is we will interchange the position of voltage source and the current marked. So earlier the voltage source was here, now we are taking it here in this position. One thing to be noted is the polarity of the voltage source. As earlier the direction of I, capital I, was in this direction, so that is why the positive terminal appears in this place. Again we will calculate the total resistance, but this time the total resistance will be seen from this side, that is from the side of the voltage source. So looking from this side, we can see that the total resistance can be found as follows. R1 will be in parallel with R2, so parallel combination of R1 and R2, then that in series with R3 and R4 will contribute to the total resistance. So in that way the total resistance is found out to be 10 ohms. Now the source current IS would be E upon RT, which comes out to be 4.5 amperes. Now again, by the current division law, as you can see, IS here will divide one in this branch and the other one in this branch, which is I, and this branch sees a resistance of 12 ohms and this branch sees a resistance of 6 ohm. So only 1/3 of the total current will be equal to I, and this comes out to be 1.5 amperes. So we can say that with the interchange of voltage source from the previous location to this new location, the current remains the same, and hence the reciprocity theorem has been verified. Now coming to the reciprocity in a two-port network. A network is said to be reciprocal if the ratio of excitation at one port to response at the other port is same if the position of excitation and responses are interchanged. This is the condition of reciprocity in a two-port network. Now we can demonstrate this with this example, as it can be seen that an excitation of V1 is given at port 1 and the response I2 dash is seen at port 2. Now the positions are interchanged and the excitation is given at port 2, which is given as V2, and the response is taken at port 1 given as I1 dash. Now this you can easily see that V1 is equal to the source voltage or the excitation voltage, and V2 is 0 as the terminals are shorted, and I2 dash is minus times of I2 when I2 is given the general convention, the sign convention. Similarly, in this case also you can see V2 is equal to the source voltage and V1 is 0 because of the short circuit at the first port, and I1 dash is minus I1. So the condition of reciprocity as given in the statement says that the excitation to the response, that is Vs upon I1 dash, remains same when the excitation and responses are interchanged. Thus for the second network also, this Vs upon I1 dash would be equal to Vs when the excitation is given at port 2 upon I2 dash, when the response is taken. Now we will look at the condition for reciprocity in Z parameters. Z parameters or the impedance parameters are given by these two equations, where V1 and V2 are dependent quantities and I1 and I2 are independent variables. So as you can see in this network, that V1 is equal to the source voltage Vs and V2 is 0 as it is short circuited, and I2 will be equal to minus times of I2 dash. So by using these two equations, which I have given here for clarification, for clarity, using the first equation, V1 is kept as Vs and the equation remains the same, but only the value of I2 will be equal to minus times of I2 dash. Now by the second equation, V2 is 0, so you can see a 0 here, and again I2 will be minus I2 dash. So by using this second equation, I1 is given in terms of I2 dash as I1 is equal to Z22 upon Z21 I2 dash. Now this value of I1 is replaced in the first equation to get an equation in terms of only Vs and I2 dash. Thus Vs upon I2 dash will be equal to Z11 into Z22 minus Z12 Z21 upon Z21. So this is Vs upon I2 dash, which we get from this network. Now the position of the excitation and responses are interchanged, and the excitation is given at port 2 and the response is taken at port 1. Thus V2 will be equal to Vs and V1 will be equal to 0, that is the short circuit terminals. I1 would be equal to minus I1 dash. Now in the similar way, using these two equations, we can find the value of I2 as Z11 upon Z12 I1 dash, and using the second equation we can get the value of Vs upon I1 dash as equal to Z11 Z22 minus Z1 Z21 upon Z12. Now using the reciprocity theorem, this whole quantity will be equal to this quantity, as you can see here. So we can simplify it as Z12 upon Z21. So this is the definition for reciprocity, or for the network to be reciprocal in terms of Z parameters. All we need to prove is that Z12 is equal to Z21. Now looking at the condition for reciprocity in Y parameters, we need to prove that the excitation by response in this network is similar to the excitation by response in this network, only that the position of the excitation and responses has been interchanged. So for Y parameters, that is the admittance parameters, we know that I1 and I2 are the dependent variables and V1 and V2 are the independent variables. Here the Y parameters are given as Y11, Y12, Y21 and Y22. So in the first network, V1, that is the voltage at port 1, would be equal to the excitation Vs. V2 will be equal to 0 because of the short circuit, and I2, as you can see, will be equal to minus times of I2 dash because of the direction of flow of current. So by using these two equations, I2 dash upon Vs is evaluated as minus Y21. Similarly, for this network also, the voltage at port 2 will be equal to Vs, that is the excitation. V1 will be equal to 0, short circuited terminals, and I1 will be equal to minus times of I2 because of the direction of current, as you can see. Now again, using these two equations, I1 dash upon Vs is evaluated as minus Y12. Now according to the reciprocity theorem, the excitation by response in the first network should be equal to the excitation by response in the second network. Thus we get the condition for reciprocity in terms of Y parameters as Y12 upon Y21. So we can say that whenever we have a two-port network and we need to prove that the network is reciprocal, we can just evaluate the y parameters, and if y12, that is this parameter y12 is equal to y21, we can say that the two-port network is reciprocal. Similarly, the condition for reciprocity in ABCD parameters in terms of the transmission parameters has been evaluated in this slide. Here in ABCD parameters there are two dependent variables, V1 and I1, and the two independent variables are V2 and I2. So the ABCD parameters are defined by these two equations. Now to find the condition for reciprocity in terms of ABCD parameters, we have the similar two networks where Vs is the excitation at port 1, I2 dash is the response at port 2. Interchanging these two at the different ports, we have the excitation at port 2 Vs and the response I1 dash at port 1. Now in a similar way as we have done previously, we use these two equations and find the value of excitation by response, that is Vs upon I2 dash in this first network. This is evaluated as equal to B. B is one of the ABCD parameter. Next, using this network and the two equations that we've again calculated excitation by response in this network as B upon AD minus BC. Now as per the reciprocity theorem, these two values, that is Vs upon I2 dash, should be equal to Vs upon I1 dash in the two different networks. So this gives the condition for reciprocity in terms of ABCD parameters as AD minus BC is equals to 1. So again, if we have a two-port network and we need to find whether the network is reciprocal or not, and we have the ABCD or the transmission parameters, we can simply find this equation, and if this equation is fulfilled, then the network is reciprocal. Now for the condition for reciprocity in terms of H parameters. In terms of H or hybrid parameters, we have the two equations given here. We have V1 as the dependent variable and another dependent variable I2. The hybrid or the H parameters are H11, H12, H21 and H22. The independent variables are I1 and V2. Now again, by the two networks, what we do is we simply find the value of Vs upon I2 dash, that is excitation by response, in terms of the hybrid parameters. Using the two equations, we get minus H11 upon H21. Similarly, for this network, we get Vs upon I1 dash as H11 upon H12. Now equating these two equations, we get the for reciprocity in terms of H parameters as H21 is equals to minus times of H12. Now the summary of reciprocity in two-port network, which we have already evaluated, is given in this table. We have calculated for Z parameters, we have calculated for Y, for T, which is nothing but ABCD parameters, and for H parameters. Now this T dash will be calculated similar to the ABCD parameters, and G parameters will be calculated similar to the H parameters. So I have not included this in this video. Now the condition for reciprocity in terms of Z parameter will be Z12 should be equal to Z21. In terms of Y parameters, Y12 should be equal to Y21. In terms of ABCD or transmission parameters, A into D minus B into C should be equal to 1. In terms of T dash or ABCD inverse parameters, A dash D dash minus B dash C dash should be equal to 1. In terms of hybrid parameters, H12 should be equal to minus H21, and in terms of G or inverse hybrid parameters, G12 should be equal to minus G21. You can calculate this yourself. Now there are certain limitations of the reciprocity theorem which are to be kept in mind while solving any network or any two-port network. The first limitation of this theorem is that it is applicable only to single source networks. Now, you cannot use this theorem when there is a network consisting of more than one sources, like a voltage source and a current source or two voltage sources. Then this theorem will not be used. That is, it is not used in multi-source network. Now the network where reciprocity theorem is applied should be linear. It is not applicable in non-linear networks. So the network should consist of only linear elements such as resistor, inductor, capacitor, coupled circuits, etc. This theorem is used in bilateral network, which consists of only bilateral components, not in case of unilateral components. The circuit should not have any time varying elements. So these are few of the limitations of the reciprocity. Thank you everyone for watching this video. Hope that you enjoyed it and it will be useful in better understanding of the topic. Thank you all.